Welcome to the deep dive. Today we're really digging into Unreal Engine 5. We've got a pile of developer reports, community feedback, docs, you name it.
Yep. And the goal here is to understand, how UE5 is actually performing out in the wild. What are the real challenges developers are hitting with this pretty advanced tech?
Exactly. We've all seen the stunning demos, Nanite, Lumen, virtual shadow maps. They look amazing. But the big question we're tackling is, do they deliver without, well, completely tanking performance?
It's about getting past the hype. For you listening, we want to unpack the why behind some of the performance issues people are seeing and how it affects making games and ultimately playing them.
Okay, so promise versus reality. Let's start with something really fundamental. Smoothness. How
Yeah.
do these games feel? Because high FPS doesn't always mean smooth, right?
That's absolutely critical. We're talking frame pacing. You can have a high number on your FPS counter, but if the frames aren't delivered consistently, well, that's when you get those micro stutters, the little hiccups that just feel bad.
And that's been a thing with UE5 games, especially on PC.
It really has. It's a common complaint, those stutters.
So what's causing it? If it's not just low frames, what's the hiccup?
Well, one of the biggest culprits, particularly on PC, seems to be shader compilation.
Ah, shaders. The instructions for the graphics card.
Exactly. On PC, the system often has to build these instructions, like on the fly, as you encounter new stuff in the game. And that process, it can take time.
How much time? Are we talking noticeable?
Oh, yeah. We've seen reports citing delays over 160 milliseconds just for compiling and linking these things.
Yes. Well, that's a big pause.
We feel that.
Wow. Okay, more than a tenth of a second.
Yeah.
Yeah, that's definitely stutter territory. But consoles are different. I heard they handle this better.
They do, yeah. It's a really interesting contrast. PlayStation 5, Xbox Series X, they usually ship with pre-built shader caches.
Meaning the heavy lifting is done beforehand?
Exactly. So you don't get those same first time you see something stutters.
Sure.
One dev made a great point managing shaders for, what do they call it, a billion different PC configs. That's just way, way harder than for the fixed hardware in a console.
Right. The PC's strength, its variety, becomes a weakness here. That totally makes sense. It's the wild west of hardware combinations.
It really is. And that complexity means PC developers using these advanced engines face this constant battle against fragmentation. It's not like a console where you know exactly what you're targeting.
So PC development is inherently tougher for this specific issue. Has Epic done anything to help PC developers with this shader stutter?
They have, yeah. Starting with UE 5.2, they introduced something called PSO pre-catching,
PSO.
pipeline state object. Basically, the idea is to compile the common shaders ahead of time, like during loading screens.
Okay, so trying to anticipate what's needed.
Right. And Epic themselves have said that newer engine versions do show less hitching because of these kinds of improvements.
That's good news. But in the meantime, what about players? Are there any tricks they're using?
We've seen some community workarounds, yeah. Some people find that locking their frame rate maybe to 120 FPS, even if their system could theoretically go higher, seems to help smooth things out,
Interesting. So maybe it helps the engine manage its workload.
possibly. And we've even seen comments, supposedly from driver devs, pointing the finger directly at that on-the-fly shader creation causing stutters. It feeds into that whole sentiment you see online, like on Reddit, where people at UE5 games just run so much worse on PC than PS5.
And the shader issue seems to be a big reason why.
It's definitely a major factor in that perception, yeah.
But it's not just shaders, right? I remember reading about the CPU becoming a problem too, especially with all the new UE5 features running.
That's another key piece. If you think about these really dense scenes, tons of nanite geometry, complex lumen lighting, the CPU, the main processor, can get absolutely hammered.
And if the CPU can't keep up?
Then your expensive graphics card
Mhm.
ends up sitting idle, waiting for instructions. We saw reports about The Last of Us Part I on PC, for example,
Right.
where the CPU was pegged at 100%, but the GPU was only doing like 40% work.
And the frame rate was stuck around 60 FPS, even with a powerful GPU.
Exactly. The CPU was the bottleneck. So yeah, these amazing visuals, especially Lumen, they can really strain the whole system, not just the graphics card.
Okay, let's zoom in on Lumen then. The dynamic global illumination and reflection system sounds fancy, looks fancy. It must be heavy, right?
Oh, it's demanding, no question. Epic's own targets are pretty revealing. For consoles, they were aiming for 30 FPS at 1080p for full quality Lumen.
Only 30 FPS.
The full quality, yeah.
Mm.
Getting to 60 FPS usually meant scaling things back quite a bit.
And community reports back this up.
Absolutely. We saw examples like Fortnite running on a really beefy card, an RTX 3080. At 4K max settings with Lumen on, people were seeing like 30 to 50 FPS,
Even with DLSS helping out.
even with DLSS upscaling. Yeah. 40 to 50, maybe.
Yeah.
It's just computationally very expensive.
What makes it so heavy? Is it just the light bounces?
That's a big part of it. Lots of dynamic lights, things that glow emissive materials mean the system has to constantly recalculate how light is spreading. Plus, Lumen often works alongside virtual shadow maps, which had their own significant cost.
Right, the new shadow system.
Yeah. And the consensus seems to be that you really need one of the very latest graphics cards, like an RTX 40 series or AMD's RDNA 3, to handle Lumen on high settings without performance just cratering.
So for everyone else, it's either lower settings or baked lighting.
Pretty much. Or disabling Lumen altogether and falling back to the older, pre-calculated static lighting methods.
Are there visual downsides to Lumen 2 beyond the performance cost, like glitches?
There can be, yeah. Some users report seeing temporal artifacts, think like shimmering or graininess, especially on moving things. Ghosting, where you see trails behind objects, can also happen, particularly with fine details.
And flickering.
Flickering, too, sometimes, especially if motion blur is turned on. And shadows on complex stuff like leaves or grass can look a bit noisy or unstable sometimes.
It sounds like a trade-off, and some devs are just opting out. You mentioned Remnant the 7.
Yeah, that was a high-profile case. They used Nanite, but they specifically didn't use Lumen. The devs said they actually designed the game expecting players to use upscaling like DLSS or FSR, partly because of the performance hit they anticipated Lumen would have.
Wow, designing around the performance cost from the start. That says a lot.
It really does. Lumen looks incredible when it works well, but it's clearly a huge resource hog and comes with its own potential visual issues.
Okay, let's switch gears to the other big headliner, Nanite. The virtualized geometry system, infinite triangles, right? What's the performance story there?
Well, Nanite's promise is huge, handling insane amounts of geometric detail by only rendering what's necessary. But it's not quite free. It has a baseline processing cost.
And overhead.
Yeah, a fixed overhead. And what's really interesting is some evidence suggests that for scenes that aren't super complex, traditional methods like well-made levels of detail, or LODs, can actually be faster.
Faster than Nanite? Really?
According to some community tests, yeah. One finding was pretty blunt. Nanite is only faster than poorly optimized non-nanite meshes. They found it could add like 1.3 milliseconds per frame compared to a scene with good traditional LODs.
So if you were already optimizing well the old way, Nanite might actually slow things down for simpler stuff.
It seems possible in some cases, yeah. And we've heard some candid comments from developers too. Some are a bit skeptical about Nanite being the best fit for all games, contrasting its use in, say, film production versus the need for high, stable frame rates in interactive games.
So maybe better for cinematics than moment-to-moment gameplay sometimes?
That's the debate. There's concern it can strain GPU memory, strain shader throughput, and the benefits really only kick in when you're dealing with genuinely massive polygon counts. Diminishing returns otherwise.
Is there an example that shows this?
Fortnite, again, is kind of telling. Even with its more stylized art, running Nanite had a similar performance impact to running Epic's own super detailed city sample demo on the same hardware.
Which suggests Nanite itself has a cost, regardless of whether you're pushing photorealism.
Exactly. It seems to have this inherent baseline cost. We've seen advice circulating, maybe disable Nanite for important gameplay meshes if your target is 60 FPS. Its real strength seems to be in those huge static environments with just millions and millions of triangles.
And developers felt Epic wasn't totally upfront about these trade-offs initially.
There was definitely some feedback along those lines, yeah. A feeling that the early documentation might have been a bit too optimistic about Nanite being a universal win.
So again, these big UE5 features, they're powerful tools, but not magic wands. You have to use them carefully.
Precisely. And it's not just raw performance numbers. We've also seen specific visual glitches and optimization headaches pop up.
Like what?
Well, there was that bug in UE 5.4, the whole artifacts, where parts of meshes using certain transparent materials would just disappear if Nanite was on.
Yikes. Was that fixed?
Thankfully, yes, that specific one got patched. But then you have the more persistent stuff, like the temporal artifacts, the ghosting, the shimmering, which often seem worse when you combine UE5's default upscaler, TSR, with Lumen and motion blur.
Okay, so the features can sometimes interact poorly.
They can. And virtual shadow maps can sometimes cause jitter or aliasing, especially on thin things like foliage. Nanite's own culling system, the thing that hides objects that are blocked from view, can occasionally cause objects to noticeably pop into existence if the camera moves really fast.
Man, it sounds like a game of whack-a-mole. Fix one thing, another pops up.
It can feel that way sometimes, yeah. And it's not just bugs. There are also feature gaps, or things these new systems don't support yet.
Like what kind of things?
Well, initially, Nanite didn't work with skeletal meshes, the meshes used for animated characters. So super detailed characters weren't really an option at first. Foliage support also came later. And certain material effects developers used a lot in UE4, like tessellation or specific ways of blending materials, just aren't compatible with Nanite right now.
So developers might have to rework existing assets or avoid certain techniques.
Exactly. And it also means that a lot of essential optimization work still relies on those older UE4 techniques, rather than everything being handled automatically by the new UE5 systems.
You'd almost expect these cutting-edge systems to have their own built-in advanced optimization paths.
You might think so, but the reality seems to be that optimizing UE5 games is often about finding the right balance, using the old tricks where needed, and being really careful about how and when you deploy the new heavy features like Lumen and Nanite.
So we've seen a pattern. The nanite mask bug, the temporal ghosting, VSM shadow jitter, lights popping in, maybe unpredictable LOD behavior with nanite. It's a complex picture.
Definitely complex.
Now, let's talk platforms. It feels like where you play these UE5 games makes a huge difference. PC versus console seems like night and day sometimes.
Oh, absolutely. The platform variations are massive. Let's start with PC.
The Wild West.
Pretty much. Performance is just all over the place. It depends so much on your specific CPU, your GPU, even how fast your storage is, because that impacts shader caching.
Right, the shader cache problem we talked about, often not pre-built on PC.
Exactly, leading to those stutters when you first start playing or enter new areas. And honestly, to get consistently high frame rates like 4K 60 with Lumen and Nanite cranked up, you generally need a really high-end, maybe even top-of-the-line GPU.
And upscaling is basically standard practice. DLSS, FSR.
Almost mandatory in many cases, yeah. Even though Epic kind of discourages thinking of TSR, their own solution, as a pure performance booster. And little things matter too, graphics drivers. Even Windows power settings can affect how smooth it feels.
Okay, so PC variable needs powerful hardware, relies on upscaling, prone to stutters without caching. What about the PlayStation 5? Fixed hardware should make things easier, right?
It generally leads to a more consistent experience, yes. The fixed hardware spec, that unified fast memory, it helps a lot. And critically, the shaders are usually pre-compiled.
So fewer stutters.
Way fewer stutters of that specific kind. PS5 games using UE5 often give you options, like a 30 FPS quality mode with better Lumen effects, and maybe 60 FPS performance mode that scales back visuals, often using dynamic resolution.
But it's not perfect. Is the CPU still a potential issue?
It can be. The PS5 CPU, while capable, isn't cutting edge by today's PC standards. In really heavy nanite and VSM scenes, it can still bottleneck performance. But the console's fast SSD and custom I/O do help a lot with streaming all that nanite data quickly.
So what's the player feedback like on PS5?
It's kind of mixed, but generally positive regarding smoothness. People report much less stutter than on many PCs. The downside is you usually have fewer graphics options to tweak yourself.
Okay, smoother but less control. How about the Xbox Series X and the Series S? Similar story.
Broadly similar, yeah. Fixed hardware helps consistency. The Series X has a bit more raw GPU power than the PS5, though it has separate memory pools, not unified. For standard rendering, the Series X can often hang with high-end PCs and UE5 games.
And Lumen on Xbox.
It typically uses a software-based approach, since the consoles lack dedicated hardware ray tracing acceleration, quite like modern PC cards. But they often use techniques like MSAA to keep the image stable. Digital Foundry analyses show both Xbox consoles can handle Lumen and Nanite pretty well at their target resolutions, like 1440p quality mode on Series X.
What about the Series S? It's less powerful.
Yeah, the Series S often relies more heavily on dynamic resolution scaling, sometimes quite aggressively, and variable refresh rate, VRR, becomes almost essential on the S to smooth out the frame rate fluctuations, which tend to be more common.
So consoles generally aim for stability, often through dynamic resolution and frame rate targets, maybe 30 or 60 FPS.
That seems to be the common approach. Lock down the experience, pre-compile shaders, target specific frame rates, and use scaling to hit them.
So if we pull back and look at the big picture across platforms.
The takeaway seems to be, consoles often offer a more consistent, predictable UE5 experience out of the box because of that locked hardware and shader pre-compilation. PC offers the potential for higher fidelity and frame rates, but it's far less predictable, and often requires significant optimization effort from devs and powerful hardware from players.
And maybe a slight edge for PS5 streaming due to memory, but PC gets things like DLSS.
Right. There's that perception about the PS5's memory and I/O maybe being better for streaming massive worlds, but yeah, consoles miss out on those NVIDIA and AMD-specific upscaling technologies that can really boost performance on PC.
It definitely sounds like Epic hasn't been standing still, though. The engine keeps evolving. How have the different UE5 versions changed things?
That's a really important aspect. UE5 isn't static. 5.0 was the big launch, visually impressive, but yeah, it had its share of bugs and, crucially, no PSO pre-caching for shavers.
Then 5.1?
5.1 brought nanite support for foliage, which was huge, more options for scaling features back, improvements to Lumen, but also some new bugs, particularly around nanite interacting with shadows.
And 5.2 was the big one for shooters.
That's when PSO pre-caching arrived, aiming directly at those PC stutters. It also improved how nanite data streams in. But Lumen was still very heavy, and nanite could still bottleneck the CPU in some cases.
Okay, then 5.3.
More optimizations for nanite and Lumen. Interestingly, some users reported worse performance in specific situations, maybe due to new underlying issues. There were also some stability problems, like crashes related to volumetric fog for some people.
And 5.4.
Further nanite fixes, including that whole artifact bug we mentioned, VSM improvements too. But again, some developers noted new, different kinds of stutters popping up. It's like whack-a-mole sometimes.
Always something new. What about the latest, 5.5?
5.5 promises more performance gains, better CPU use, better multi-GPU support, refinements to TSR. But even with all that, you still see the community talking about the hashtag stutter struggle. It shows it's an ongoing process.
It really highlights how complex this engine is. Each update fixes things, improves things, but maybe introduces new wrinkles. Let's make this more concrete. Can we look at some specific games? How did they fare?
Yeah, looking at actual released games is super insightful. Take Remnant 2, UE 5.3. Use nanite heavily, but skip Lumen entirely.
And the result?
PC launch was rough for many. DLSS or FSR felt almost required for decent frame rates. Some reviews felt the graphics looked a bit dated, despite UE5. Even high-end GPUs weren't always smooth. And the minimum specs got a lot of criticism. Felt like maybe optimization wasn't the top priority before launch.
Okay, what about The Last of Us Part 1? That was a UE5 core, right?
Yeah, and that one really highlighted the CPU bottleneck issue on PC. Reports of 100% CPU usage, choppy frame pacing. The complex shaders seemed to really tax the CPU. It became kind of a poster child for the UE5 is rough on PC sentiment for a while.
Even Epic's own game, Fortnite.
Even Fortnite.
Yeah.
After the UE5 upgrade, performance wasn't always great. You could have relatively simple-looking scenes, but with nanite and Lumen on, you might only be getting 60-something FPS on a decent card at 1080p.
Which really shows the baseline cost of these features.
Exactly. Epic has patched it continuously, and they even added an option to turn nanite off in a performance mode.
How about smaller games, like Fort Solis?
Fort Solis was interesting. Indie scale, but used nanite and Lumen. PC performance was, well, pretty bad at launch.
Yeah.
Even top cards like the 4090 struggled to hold 60 FPS at 4K lowest settings.
Wow.
What was notable there was that AMD and NVIDIA cards performed similarly, suggesting nanite itself, the geometry processing, was the main bottleneck, not just ray tracing or something specific to one vendor. It sparked criticism about games seemingly expecting users to have absolute top-tier hardware.
So the pattern seems to be heavy reliance on upscaling, frame rate caps, post-launch patching.
That's a very common thread, yeah.
Yeah.
And analyses like from Digital Foundry often show consoles getting great visuals with VSM and nanite, but frequently locked at 30 FPS. And sometimes console ports have unique issues too, like texture streaming problems that didn't show up on PC. It's a real mixed bag.
It really feels like developers are still figuring out how to best use this engine without breaking performance budgets. What's the vibe from the community, both devs and players?
Oh, people are definitely talking about it. You hear devs saying things like, UE5 looks a bit better but runs way worse, you know?
Yeah.
Calls to focus more on native performance instead of just assuming everyone will use upscaling.
And the hashtag stutter struggle.
That hashtag really captured the frustration, especially among PC gamers, with the frame pacing issues. Shader compilation gets blamed a lot. Epic knows about it. They're trying things like the PSO packaging, but the perception lingers.
Do developers feel the documentation matches reality?
There's some feeling that maybe the official docs paint a rosier picture than reality sometimes. We've heard devs say that, in practice, good old-fashioned LOD optimization can still beat nanite for performance in many common scenarios.
And players are sharing tips?
Yeah, trying things like disabling certain network features, making sure the game is on an SSD, using G-Sync or FreeSync monitors. anything to try and smooth things out. And definitely lots of complaints when PC ports launch feeling unfinished.
What about tech analysts or creators?
People who break down game tech, yeah, they've raised concerns, questioning if Nanite is always worth the performance cost, pointing to maybe a wider industry issue of pushing graphics fidelity faster than optimization techniques or hardware can keep up, like graphics advanced, optimization declined.
Digital Foundry tracks this stuff closely too, right?
They do. They've documented the stutter struggle, noted the improvements in newer UE versions, but also consistently pointed out the challenges, especially on consoles trying to run demanding features like Lumen at high quality.
And developers themselves are admitting this.
At events like GDC, yeah. You hear developers acknowledging Nanite maybe started with more of a film cinematics focus and saying that for games, especially aiming for 60 FPS, you often have to be pragmatic and cut back or disable certain UE5 features.
So boiling it all down, UE5 offers amazing visuals, but there's a definite cost, right? What's the core advice?
Absolutely. The big takeaway is that next-gen visuals demand careful trade-offs. The core advice for developers seems to be selective. Don't just turn everything on max.
Like disable Nanite for smaller things.
Yeah, or dynamic things where the benefit isn't huge. Maybe limit lumens quality or range, or use baked lighting where it makes sense. And really tune those scalability settings for your target platforms.
And for players, it depends on the platform.
Pretty much. On PC, you likely need a strong GPU, hope for good PSO caching in the game build, use DLSS FSR, and keep drivers updated for the best shot at high frame rates. On PS5 or Xbox, you're generally getting a more locked-down experience, often using dynamic resolution to hit 30 or 60 FPS targets, leading to more consistency but less control. VRR helps smooth things out, especially on Series S.
An engine version matters too. We saw 5.0 was rougher.
Definitely. Early versions lacked key optimizations like PSO caching and just seemed generally less performant. Epic themselves targeted 30 FPS more often back then. Later versions have generally improved things, even if new issues sometimes crop up.
It really paints a picture of UE5 as this incredibly powerful, but also very demanding engine. Developers are clearly still on a learning curve.
That sums it up perfectly. The potential is immense. We see that in the best moments, but realizing that potential smoothly and consistently. That requires ongoing work, both from Epic refining the engine and from developers learning the best practices to manage its complexity without overwhelming our hardware.
Which leaves us with a final thought, something for you to chew on. With these ongoing performance hurdles, is this push for ultimate photorealism always going to run ahead of what typical hardware can handle? Or things like upscaling and performance modes just the new normal from now on? And what does that mean for game development and for us as players in the long run?
A big question to ponder.
Thanks for taking this deep dive with us today.